So, derivatives in polar. I treat them exactly like derivatives in parametrics. So, what's the formula for derivative in parametric? dy dt over dx dt. But in polar, we're going to call it dy d theta over dx d theta. But what you're given, guys, is this polar equation, r equals some function in theta, correct? So what is x and what is y, you may ask? We have looked at this one time before, but if I just draw this random xy in rectangular, this length is which value? The x. This vertical length is and the hypotenuse is the radius, r, the r value, right? So, and the theta value would be right tucked in there, correct? So if I wanted to relate the y value with the r, what trig function would I use? Sine. The sine of theta equals r opposite over hypotenuse, y over r, right? So what would y actually equal? Multiply both sides by r. R sine theta. Did we do these notes the last time? Okay. And then cosine of theta is x over r. So what does x equal? R cosine theta. So using these two, I guess, conversion formulas, so to speak, then that's what we use to do dy dx. Your book wants to, I'm assuming, have you memorized, which is like the stupidest thing, but look at what they put for dy dx. F of theta cosine theta plus f prime theta. Like, are people literally going to memorize that? No. And honestly, I mean, it would be the product rule, because what you would do is you'd substitute for the r, the f of theta, okay? You would substitute, and you could have a product rule for the top and the bottom. However, you might not have a product rule if you do some simplifying first. So why would you memorize the whole long product formula if you don't need to? You know me, I'm less about memorizing and more about actually knowing where it came from, if at all possible, right? So let's get an example of finding the derivative. Let's just say r equals 2 cosine theta. And I want you to find the slope of the tangent at the point (1 pi over 3). That would be the polar point, right? They might not. What if they didn't give us the polar point? What if they gave us (1/2, comma, √3/2)? And I think this should have been 2. And And this should have been 1 and root 3. Sorry. So what if they didn't give us the polar point, they gave us the rectangular coordinates? Just convert it. I mean, honestly, if they gave you the polar point and it was a nice special angle, right, pi over 3, couldn't you figure out that that's a 30 up there and the x value would be 1 and the y value would be root 3, or vice versa? If the x value was 1, the y value was root 3, oh, I know that's a 30, 60, 90, and the hypotenuse is 2, right? So whichever version you can figure out, that theta had to be pi over 3, correct? So we're finding the slope of the tangent when theta equals pi over 3. Agreed? So let's do our conversions. What does y equal? R times sine theta, right? What does x equal? R, replace the r with 2 cosine theta, times cosine theta. If you remember in pre-calc, of course, x is easy. What is this? 2 cosine squared theta, right? Anybody have any recollection on what 2 sine theta cosine theta is really the same as?
Oh, cosine squared.
It's the double angle formula for sine. The sine of 2 theta is 2 sine theta cosine theta. It's the one double angle formula. I said, y'all, if you can remember this one, for Calc BC, you're going to be a step ahead. Because,
You never told us that.
oh yeah, I did. I tell it to them every year. Every year since I've been teaching BC. I've said, hey, pre-calc kids. So, this can be replaced with what? Sine 2 theta, which makes our dy d theta like super easy, doesn't it? So, you with us? Dy dx now will equal what? 2 cosine 2 theta on top. What on the bottom? Got a little chain rule. 4. Leave the blob alone. Lower the power by 1. Derivative of the blob would be negative sine theta. Now, I mean, you could actually simplify this as well, I believe. But let's just go ahead and plug in pi over 3. What is 2 times pi over 3? 2 pi over 3, which is a 60 degree there, negative 1 root 3. What is the cosine? Negative 1/2 times 2 would be, and the cosine of 1 pi over 3 is 1/2, right? The sine, I believe, is root 3 over 2, correct? And negative 4 times that would cancel out. Is that just negative root 3? So we have our dy dx at that point. Could I write the equation of the tangent line? I've actually found the rectangular coordinates, so yes, I could. Y minus y1, slope, x minus x1. just, do I?
Root 3 or root 2 for the y minus?
I think I said root 3 and I wrote root 2. I don't know what I'm doing. Good call. All right, so let's go ahead and look at what does 2 cosine theta look like when it's graphed? I think it's just a circle over there. All right, at the point 1, root 3, isn't that a point like somewhere right around there? In fact, I'm just going to go and go pi over 3. I'm going to go art. No, not art. I can't do theta, can I? All right. But, all right, picture that circle right there. Let's go back to function mode and graph our equation to see if in our minds it makes sense. 1 divided by root 3, x minus 1. Is that going to be plus root 3? What?
You had stuff.
I had other stuff in there. Oh, phooey. So it didn't replace it?
17. Guess so.
Delete. Delete, 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 delete.
Guess what's the number?
Oh, no.
Boom.
I was just clear.
It's the whole list.
What in the world? That was minus a 1, right? But then we had to add over the root 3. All right, let's check it. Is this correct? 1 over root 3 is the slope. X minus 1. Take the root 3 over. What?
You
You had like a random,
All right, you were right. I should have just... Where did the exponent go?
very end. One more over there. It won't let you go on.
I deleted it. I thought I deleted it. But if we had superimposed that circle right there, does it make sense? Yeah. All right. So that is finding slopes, finding an equation of the tangent line. We've done those for 2 years now, right? You feel good about those. The real issue just becomes like, you know, finding finding the values that you need to go to. Sketch a graph of the polar equation and find the tangent at the pole. So we need vertical and horizontal tangents. We graphed, we did a tangent, so we need the tangents at the pole, and we need the horizontal and vertical tangents. But if I just have my equation right here, how would I figure out where the tangents are vertical and where they're horizontal?
If like the bond equals
We'd have a vertical tangent if dy d theta dx d theta, the bottom equals 0, right? And where we have horizontal ones?
the top.
Yeah, dy d theta equals 0. So this bottom equals 0 when the cosine equals 0. Now, here's the deal. It can't be both vertical and horizontal, correct? So we can't, 0 over 0 really might be kind of anything, right? So where is dx d theta going to equal 0? When the cosine is 0 and when the sine is 0?
Just Oh, wait, no, yeah.
Give me some values. 0 was for sine pi, negative pi. What about cosine?
Pi over 2.
Pi over 2, 3 pi over 2, negative pi over 2. All right, so those are ones that we can check for sure. How about dy d theta equals 0?
Pi over 2.
All right, cosine of 2 theta equals 0.
Oh,
So 2 theta equals pi over 2, is that correct? What would theta be then?
pi over 4.
Pi over 4. 3 pi over 2, the next one. So 3 pi over 4, does that make sense? Do we have any more? I mean, we could go to negative pi over 2, which would be like negative pi over 4. So let's go back to our circle. Go back to polar mode. Have y'all ever used sequential mode? I don't have a clue what that one is. So, at 0, does it make sense we could have a vertical tangent right there? Absolutely. At pi or negative pi, vertical tangents. So I like these. Pi over 2. I think it's going to be vertical at pi over 2, don't you? Because here's 0. As we move around, here's like pi over, I don't know. Pi over 4 is right there. Pi over 3, you know. And then we get to pi over 2. I say it's vertical again. How long do you think it takes to trace around that circle? What was your guess? I think you're right. I think it's pi units. Because here to here was from 0 to pi over 2, wasn't it?
Yeah.
Pi over 2 to pi. Yeah. So I think it happens at 0, pi over 2. 3 pi over 2 would just head back in the same spot, wouldn't it? So all of those turned out to work, didn't they? For the horizontal ones now, would it make sense that this is this horizontal at pi over 4? Is that exactly? Pi over 4 works. 3 pi over 4, but if the r is negative, it would be right there, wouldn't it? So I believe all of those worked too. Yeah,
Can I go to that?
yeah. So we got our equations. We actually figured out where the slopes of the tangent are vertical and horizontal. Now, the tangents at the pole, the last little thing. The pole essentially is the origin, okay? But are the polar points, this is rectangular, are the polar points going to always read as like 0, 0? It could be 0 in any angle, couldn't it? Any theta, as long as the r value is 0. So it says the tangents at the pole are where r equals 0, or f of theta, right? But, not by, but f prime of theta is not 0. And then you would just have theta equals some number. This would be a tangent at the pole, right? It would just be an angled line, whatever that angle turned out to be. So let's do an example of finding a tangent at the pole.
Is theta equal?
Yeah.
Alpha, that's just another, just a number. Can we sketch the graph of this polar equation by hand? Y'all got your graph sheets handy? Oh, I bet you never got one, did you? There were a couple on mine. All right, so I know I officially turned this upside down, but you know, it's okay. Maybe I shouldn't turn it upside down. I'll just turn it this way. All right, so R equals 3 times 1 minus. So what is the cosine of 0, y'all? 1. 1 minus 1 is 0. Where's another good cosine? Cosine of pi over 3 is a half, right?
Yes.
60 degrees. The adjacent is 1. The hypotenuse is 2. Yeah. Cosine is a half. What's 1 minus a half?
Negative. Yes.
Positive 1/2.
No.
3 times a half would be 3 halves, right? So we're starting here. We're getting these decimals, but then we're going to have 3 halves. What happens at pi over 2 cosine is 0? What's 3 minus 0? 3. So what about 2 pi over 3? The adjacent is negative 1, right? So 1 minus a negative 1/2. 1 1/2, or 3 halves, times 3 would be 9 halves, 4.5. Oh, we're getting way big, aren't we? By the time we get over to pi, cosine is negative 1, right? 1 minus a negative 1 is plus 1. 3 times 2 is 6. 1, 2, 3, 4, 5. No. Yeah, 3 times 2. Is that right? 6. So we go there. Come back around. What happens at negative? Negative pi over, or I guess we call that 5 pi over 3. Positive. So we're gonna have symmetry, aren't we? 1.5. 1, 2, 3. 1, 2, 3. Oh, gracious. Oh, 1, 2, 3, 4.5. Oh, I can't even draw upside down. I have to turn my paper usually. Looks like a perfect little heart. Uh-oh, I'm showing a loop from the last time. Are we gonna go negative? Let's just look and see what, that might have been another one. Make sure we're right. 3 times 1 minus. I think we got it right. Yeah, we got it all, didn't we? Let's go ahead and show how it's traced. I did it from 0 to 3 pi just to show. When it traces around, it just keeps going back over the same graph, right? So, the tangents at the pole what is r prime? 3 minus 3 cosine theta, right? What's r prime? Okay. The only places that I see that it hits 0 is at 0 and 2 pi, right? What's the sign of 0 and the sign of 2 pi? 0. So we have no tangents at the pole on this particular one.
Why was it?
Remember, the definition of tangent at the pole says it's the places where r equals 0, but f prime, in other words, just plain old r prime of theta, does not equal 0. And when I took the derivative, which is not really dy dx at all, but I just took the derivative of this, turns out it's 0 at the only place that the function itself hits 0, right? Or the polar function. I'm trying to see if I have another one that, see, look at this one right here. I think this one is r equals 3 cosine of 2 theta, pretty sure. Graph it, while I'm answering this, graph it on your calculator and make sure I'm right. This is Mrs. Washington. Uh-huh. Yes. Okay, can I send her to you in like 5 minutes? Okay, thanks. All right. Susanna, in 5 minutes. And you heard me say her.
Where?
And was this correct?
Yeah.
Okay.
Where am I supposed to go with that?
To Ms. Snell. Okay. But there are several places that we hit the origin, right? Where is the first place that a cosine graph hits 0? Well, when 2 theta equals pi over 2, that's actually at pi over what? So we actually do have one spot. What's the derivative of r? -6 sine theta, or 2 theta, sorry. And the sine of 2 times pi over 4, pi over 2, is not 0. So does anybody know what that slope would probably be? Pi over, or the angle would be pi over 4, wouldn't it? So theta equals pi over 4 is the tangent at the pole. And that's going to be the tangent at the pole at this point and when it comes around this way. But what about over here? What angle does it hit 0 again over here? Theta equals 3 pi over 4. Could we also call it negative pi over 4? And could we also call this one negative 3 pi over 4? Those are the tangents at the pole, where we can, essentially, we find that angle, and we don't even have to do equations or slopes or whatever. All right. Those are the polar form. What if I asked you to turn that into a rectangular equation of the tangent line at the pole? What's the slope of pi over 4? 1. So this one rectangularly would just be y equals 1x, wouldn't it? What about this one rectangularly? Negative 1x. It was almost too easy. All right. So hopefully that will get you through the rest of that assignment. Page 739. What was that last set? 63 to 91. So there's some that I'm just asking you to graph by hand, because I do want you to practice the idea of moving around the polar coordinates and plotting, making a theta R chart, right? All right, you can go to see Miss Snell.